So here we go. If so, this is what we've got. Okay. What if I asked?
Speak to them, that's right. I'll make a message.
So what if I draw this picture and I say how much is in between negative 0.65 and 0.24? How much is in between there and there? No, use the table and give me an accurate answer.
And then those numbers I'll subtract from each other, right?
Okay, so figure. I mean, do the work, figure it out. Okay, I'll write down an answer up on the board in a moment here.
Okay.
No need to shout anything out. All right, do we get an answer? Do we get 0.337? All right, yes.
Wait.
All right, let's talk about this, okay? Here I want to know what's this weird shaped piece here, okay? What I basically want to know is how much is in this piece right here, okay? I got 0.337 is the answer here. How much is in here? Well, the way I'm going to find it is I'm going to say how much is to the left of 0.24, okay? And I look up 0.24, and the area to the left of 0.24 is 0.5948. 0.5948 over there. And then I'm going to say, well, I'm just going to take a knife and chop off the amount that's to the left of negative 0.65. So I look up negative 0.65, and I get 0.2578 over here.
Yes.
So if this piece is 0.2578, and I chop that off, how much is left? 0.5948 minus 0.2578, 0.337, and that's how much is in between them.
Wait a minute. Don't you have to add?
You don't have to add anything.
Don't you have to add those two figures and then get -1?
Nope.
I don't understand.
Alright, I'm saying how much is in this piece right here? Well, I'm going to take this piece right here, everything to the left of 0.24, and I'm going to cut off everything that's to the left of negative 0.65. So I'm subtracting the area to the left of negative 0.65 from the total area to the left of positive 0.24. And I'm getting the area in between 0.337.
Ah, sorry. I thought so. 0.24 is This area.
Yes.
Ah, okay.
Your 0.24 is the area
Okay.
to the table always gives you the area to the
Okay,
left.
okay, okay, okay. I get it, I get it. So,
Alright, what if I said how much is in between z equals -1 and 1? How much is in between z equals -2 and 2? And how much is in between z equals -3 and 3?
okay.
Can you guys get this?
Is that 0.2, 0.3?
No, these are
One.
whole numbers.
Okay.
1 and -1, whole numbers 2 and -2.
Yeah.
There's no space in this bloody table. Everything's full.
But they're a whole number.
Yes.
When you asked us, between -1 and 1, why did you put subtract where -1 was instead of vice versa? Like, what is the rule to subtract what from what?
So, can you have a negative area? No. So I have to subtract the larger, smaller number from the larger number. Okay.
Always do that, smaller.
I mean, if you're going for between, right? And the table always gives you the area to the left. Table always gives you the area to the left. Okay, do any of these numbers look kind of familiar? Alright, so did we all get these numbers? 0.6826, 0.9544, 0.9974? Okay. Well, you can go through your notes and check, okay? This gives rise to what we call the empirical rule, alright, which is a rule of thumb or guide, and it says anything that follows the normal model, about 68% of the data, so a little bit more than 2/3 of the data, fall within one standard deviation of the mean. That's what z-1 and z1 represent. So this is about 68%. Okay? And remember, I said about 95% is within 2. That 95% comes from this number, 0.9544, so about 95%. And then within 3 standard deviations, we have almost 1. Not quite, but almost. So almost 100%, 99.7%. Okay, within 3 standard deviations. And then, so this is within 2 standard deviations of the mean. And this is about 68% is within 1 standard deviation of the mean. Alright, do you guys remember how to find z-scores?
Yes.
Yes? Okay. Well then let's put all of our knowledge together and tell me if you can give me an answer here, alright? So I'm going to say IQ scores follow the normal distribution. Okay, the mean is an IQ of 100. The standard deviation is an IQ of 16, or 16 IQ points. Okay, we can sometimes we write this in shorthand. Okay, there's shortcut notation, and this would say IQ. This. Okay, so just this one line here, IQ squiggle. Okay, means follows. N for normal, with mean 100, standard deviation 16. Okay, this is shorthand for everything that I've written up here. The IQ scores follow the normal distribution. The mean is 100. The standard deviation is 16. Okay. So I'm going to ask, what percent of people have IQ scores over 120? So what percentage of people have IQs over 120 points?
When you say percentage, you talk about the shaded part, right?
Well, we gotta figure this out, okay? So here's, take a minute, I'll,
You have to use the table.
you're gonna have to use the table.
Okay.
89.8.
It's part of the way there. So you're on the right track. You're on the right track. Okay. So you have to reread the question. You guys need a hint? So you gotta figure out z-scores. Okay, so you
Yes.
remember how to get a z-score? Because the table only tells you in relation to z-scores, not IQ scores. We didn't make a separate normal table just for IQ scores. We're gonna have to use the table that's designed for z-scores.
What is this? What is N?
N means normal. This means normal distribution.
Meeting on something else, or are we just?
No, all right. Did you guys get an answer? Okay. Did you guys get 10.56%? 0.1056? Good. All right. So let's solve this for those of you who didn't get 0.1056. Okay. It says what percentage of people have IQ scores over 120? And it says the mean is 100 and the standard deviation is 16. So let's draw a little picture here. What number goes in the middle?
100.
100. This is the mean.
Yeah.
What is the z-score associated with 100? The z-score is 0. How many standard deviations are we from the mean? When we're at 100, we're 0 standard deviations from the mean. Okay. Where am I drawing an IQ score? Okay. I want to know what percentage of people have IQs over 120. So 120 is bigger than 100. So I'm drawing a line right here. And I want to know what percentage of people have scores over. So am I going to shade this side or am I going to shade this side?
Right.
I'm going to shade to the right.
Right.
I want to know how much is over here,
Oh,
right? How much is
Above.
over 120? Okay, so what is the z-score that corresponds to 120? Okay, I'm going to do 120 minus 100, so that tells me I'm 20 points above the mean. And each standard deviation is 16 points. So that tells me I'm 1 1/4 or 1.25 standard deviations above the mean. I go to my z-table and I look up 1.25. So I go to the row 1.2 and the column 0.05. And so the area to the left, so remember the table always gives you the area to the left from the table is equal to 0.8944. Okay. So 0.8944 is over here. This is the area to the left of 120. What percentage of people have IQs less than 120? 89.44% or 0.8944. What proportion of people have IQs lower than 120? Almost 90%, 89%. What percentage of people have IQs over 120? You have to do 1 minus this, okay? So 1 minus 0.8944 gives me 0.1056. Now be careful, don't do 100% minus 0.8944. If you do 100 minus 0.8944, you're going to get a totally wrong answer. You have to either do 1 minus or 100% minus 89.44%. So keep your decimals and percentages straight. Is that okay? Yes.
Okay.
Anna.
sorry if I sound like an idiot, but from the beginning, the mean is 100, and so you see 120, which is that the first one after 100? The first z-score after 100?
This is a continuous. I'm not sure what you're.
Okay, so I thought it would be like 100 plus SD, standard deviation, so it would be 116. Would be the next z-score.
That would be a z-score of 1. Okay, that would tell us we're 1 standard
Z-score
deviation.
is
Yeah.
1.25.
Okay, but with somebody who has an IQ of 120, their z-score is not 1. Their z-score is 1.25. So you have to.
But how did you get that?
Do you remember how to find a z-score?
Yes.
Okay.
You,
So
you
how do you
add,
find a z-score?
you basically add
No.
the standard deviation to the mean.
That's not how we find a z-score. Okay? To find a z-score, we have to find out how far we are from the mean, and then we take that distance, and then we do what? We divide by how big a standard deviation is. So remember, a z-score is whatever number we are, x minus, and in this case, because we're talking about a distribution, we subtract off the mean, and we divide by the standard deviation. There's no addition here. Okay? X minus mu over sigma. Before it was z is equal to x minus x bar over s. Okay? Now we're using mu and sigma. It's the same idea.
So you can still write the second way.
You can write it the second way. It's technically not correct, but it's
So
the
what
same
is
way.
this then that I did here?
You're finding out. You're basically creating intervals, but those aren't z-scores. Okay? You're marking off where things are. Okay, so let's. Is that okay? I wish we could do another example, but I don't think we're gonna have time for that. Okay?
Question?
Please
Yes.
do.
Once we just find the number on the table, we always subtract 1 from that.
No, not always. Not always. Okay. It depends, right? If I asked what percentage of people have IQs below 120, you just use the number in the table. The only reason why we subtracted it from 1 is because I said what percentage of people have IQs over 120. So you have to read the question and you have to decide: am I shading the area to the left or am I shading the area to the right? Yeah, David.
Couldn't we have gone just to 100 minus 120 over the standard deviation and gone straight to the
That's exactly what we did.
6.56 instead of 120 minus 100 and then just have to do the subtraction?
I think that's exactly what we did.
What I-
Maybe I don't understand your question.
No, what I saw you did was 120 minus 100.
Yes.
Then we had to go over the other side of the table and subtract to get to the negative side. So if we did 100 minus 120, it gives us a negative number, pulls up the 10,
Oh,
1056.
no, you cannot do that, alright?
Why not?
Because you are, that only worked in a coincidence, well, not a coincidence, but it only works because I'm asking for the area to the right. Now, what you can do is you can look up, you can say, because you always got to ask, how far am I from the mean? And so you're always going to subtract the mean, and you're going to get a positive number. If at that moment you want to change it from positive to negative, you can. But it's not, if you subtract 120 from 100, it's just a happy mistake that you end up getting the negative version. Okay, so don't do that. You're just like taking too many shortcuts and you happen to get the right way. Okay, but the steps are wrong. Okay, so don't. I mean, sometimes that happens where you do the things the wrong way and you end up getting the right answer. But I can't teach that and say that's how you should do it.
Sorry, can I see one more thing? So the 0.1056 is the unshaded area. Is that correct?
No, this 0.1056 is the shaded area to the right. Okay? Okay? Alright. Okay. We're taking a little bit too long. I got more topics to cover here, okay? We'll get it,
We
alright?
need to understand before we.
Right, but I gotta make sure you're prepared for
Can you do
the
another
exam.
sample after you've covered everything?
If you want to stay here till 11, sure. Okay. Let's. All right. What if I said, what is the IQ that corresponds? So let's say a school district, has programs for, special needs students. And let's say, but to qualify, you need to be in the bottom 3%, okay? So what is the IQ that, I guess, separates the bottom 3% from the rest of the population? And again, shorthand IQ. Okay, you know what? I wish I could just say, take this time and go through it. I'm going to go through the answer here. Okay, what I'll do is I'll also put up another question and I'll put the answer on the corner, and I will leave it as an exercise for you guys to do to test out. But we just don't have time to kind of give you that time and work through it. Okay, so this is this time I'm searching not for the area, but for the IQ score. Okay, what does my picture look like? I have a little wedge shaded over here, and how much is in this shaded area? 3%. 3%. I've got 3% in the shaded little wedge. Okay, so that means 0.03 right there. And I'm looking for, what is the IQ that gives me 3% in this shaded wedge? Does that make sense? So, I don't know what the IQ is, but I do know it's for sure going to be less than 100, right? Because 100 is the mean, so I do know for sure it's going to be less than 100. What I need to do is I got to figure out the z-score that's going to give me 3%. What is the z-score? What z gives me 0.03 in the area to the left? So what that means, okay, and this is important, is that when I go to my z table, okay, when I go to the normal table, I'm going to look for 0.0300, the number closest to 3% in this part of the table. In this part of the table, I do not look up 0.03. Does Does that make sense? I do not look up 0.03 because that's going to give me 0.5120. That's not the number I want. I need to look up what number gives me 3%, or the number closest to 3%. And the number that gives me, the thing that gives me closest to 3% is negative 1.88. Okay, 1.8 and 0.8. Okay, it's not exactly 3%, but it's pretty darn close. So z is equal to negative 1.88. Okay, and that gives me an area of 0.0301, which is pretty darn close to 0.0300. Okay, and all you're going to do is you're just going to pick the number that gives you the closest one. Okay, just take the number that gives you the closest one. Okay, so this tells me that a z-score of negative 1.88 gives me 3% in the area to the left. Okay, I just want to make sure that's okay. So we're using a reverse lookup here. Okay, I'm basically saying I'm trying to find the z-score that's going to give me 3% in the area, and that's z-score is negative 1.88. Okay. So what z gives me 3% in the area to the left? Z equals negative 1.88. What does a z of negative 1.88 mean? It means I am 1.88 standard deviations below the mean. Okay. So there's a few ways we can go about this. Okay. One is we just understand. Okay. If my mean is 100, okay, and I'm 1.88 standard deviations below it, I'm going to just subtract 1.88, and how big is each standard deviation? 16. So I'm going to multiply this by 16, and this is how many points I'm going to subtract from 100. And I do 100 minus 1.88 times 16. Okay, and this gives me an IQ of 69.92. Okay, so basically an IQ of 70 is what's going to separate the bottom 3% from the rest of the population. Okay, and that would kind of be the cutoff between special needs and regular students. Okay, so 69.92. Yes.
How did you multiply the z-score by the standard deviation?
Yeah. Okay. Well, what is a z-score? Z-score is how many standard deviations am I below the mean, right? So a z-score of negative 1.88 says I'm 1.88 standard deviations below the mean. How big is a standard deviation? 16 points. 16 points. So I'm going to multiply that by 16, which gives me basically 30.008. Okay. So I'm 30.08 points, IQ points below the mean. What was my mean? 100. So I'm going to do 100 minus this, and that gives me 69.92. Okay. The other way, which is perfectly valid, and some of you guys are going to prefer this because it's like formulas, and formulas are your crutches, and they're like you love them for whatever reason. Okay. But sometimes you lose the meaning of what's happening here. You just say z is equal to negative 1.88. I don't know what x is, but I do know mu is 100 and sigma is 16, and I'm going to solve for x. Multiply both sides by 16, add 100 to both sides. Add 100 to both sides, and you get x is equal, 100 plus 16 times negative 1.88. Okay? It's exactly the same math that we did over here, but
if we do it the first way you did it, but let's say it was not negative, the z-score was positive,
yeah,
would you add it?
Then you would add it, exactly.
Okay.
But if it was positive, what does that mean? It's what is the IQ that separates the top 3% from the rest of the population. So who's going to go to, join Mensa or whatever, right? So that's what we got. All right. So I'm gonna put up a few examples here, and I'm just gonna punch out the numbers, the answers for you guys. I have to leave it for you to do on your own as a way to study and prepare for the midterm exam. Because you're definitely going to see some problems like this, and I just wish we had more time to go over all of this, but we don't.
Over a few
early next week.
Yeah, I mean, we can go, I mean, we're gonna have the office hours, but, so I'm gonna post some things up and then, or just put a few problems here. And then we got one more topic that we gotta cover, okay? Called the binomial, so. Alright, so let's say, height of women. So write these problems down in your notes, and then on a different sheet of paper or on the following sheet, you can put these answers up, okay? Or put these answers in, and it's an exercise for you to go through and figure these out, okay? Alright, you know what? I'm not even going to bother showing the full work. I'm just going to give you answers here, okay?
Can you put up a video?
I don't think I can. I mean, I've got plenty of videos of homework problem examples. Okay.
This is video. It's video.
So this is I think. these are your answers. And write that down on maybe the following sheet in your notes, and go over that. Okay, you'll definitely see some problems like this. All right, you might need to review what a percentile is and all of that stuff, but. Okay, so don't try to solve these now. Just write the answers, because we gotta move on to the next topic. All right. So this last topic, we're just gonna kind of go. We could go really in depth, but we're not gonna get the in-depth treatment. Okay, but it's called the binomial distribution. Okay, so again, this is a random variable, random distribution. It's a model of what happens when we do a random experiment, okay, or random thing. And in this case, the random experiment is we're going to try basically the same thing over numerous times. Okay, so example is I could flip a coin 10 times, or I could try to take, I could try to shoot free throws 7 times. I can try, I can have 8 kids and see how many girls are born, okay? So we repeat the same thing the same random trial, okay, n times. Each time we repeat it, okay, we succeed, and succeed is an arbitrary label with probability p. Okay, so if p is the probability that I succeed, what is the probability that I fail? 1 minus p. Failing is the complement of succeeding. So probability of failing is 1 minus p. Okay, good. Each trial is independent. Of each other. And we are interested in the probability of getting a certain number of successes. Getting X successes. Okay. So write all of that down. Here's an example. And really learn these examples and things, because, well, you gotta, part of the test is being able to read a problem and recognize, is this binomial? Is this a normal distribution problem? Is this just a probability problem? Okay? Because a lot of these questions are going to ask, what's the probability of this or whatever? And you got to still be able to distinguish this. Okay? So here's an example. I flip a coin 20 times. The probability of it landing heads probability that the coin lands heads uh, 12 times. It's not 0.5. Okay, and that's one example. All right, and anytime you see an example and it's binomial, you have to be able to identify n, p, and x. N, p, and x. And they're all listed up there. We repeat the same trial n times. What is my n in this case? 20. I'm flipping a coin 20 times. N is 20. Each time we repeat it, we succeed, whatever succeed may be. Landing heads, landing tails, the ball going through the hoop, whatever, with probability p. What is my p in this case? 0.5. Okay. And we are interested in getting x successes. What is my x?
12.
12. My n, p, and x is 12. Good. All right. I go to Vegas and play roulette. Okay. Let's just say, for simplicity's sake, the probability of winning on a certain number is 2%. Okay. I play 50 games. What is the probability I never win? Okay. In this case, n, p, x. What is my n?
50 games.
50. I'm playing 50 games. I repeat the same thing, okay? What's the probability p?
0.02.
0.02. And what is x? 0. I'm interested in 0 wins. Let's do one more, and then we'll talk about how to answer these questions. There is a giant tub of M&Ms. Okay. 20% of the M&Ms are red. I grab a handful of 9 M&Ms. What is the probability that I get 3 or 4 red M&Ms? What's my n? What's my p? What's my x? Okay, what is n? 9. Okay, I'm grabbing 9 M&Ms. What's the probability of success? 0.2. 20% of the M&Ms are red. And what is x? 3 or 4. So I'm looking for x equals 3 or x equals 4. Okay. Let's try to answer this. So in the table, flip from page A2 and A3 to A4 and A5. This is binomial probabilities. And you can see, so there's a formula for all of these things, but we're just going to use the table. Okay? And you can look up n, p, and x, okay? So where n is equal to 9, that's going to be at the top of page A5. You see that? All right, and you can see n equals 9, and then next to n there's an x, and x goes from 0 to 9. Because when you pick 9 M&Ms, or 9 whatever it is, okay, what's the fewest number of red M&Ms you can see? 0. 0 is the fewest number of red M&Ms you can see. What's the most number of red M&Ms you can see? 9. Okay? So in this case, what's the probability that I'm going to see exactly 3 M&Ms? Okay, so probability of exactly 3 out of 9 are red. The answer there is I'm going to go to n equals 9, the row for x is equal to 3, and the column for 0.2. Yeah, I'm sorry. It will not hurt you. It will not hurt you. Okay? So the probability that exactly 3 out of the 9 are red is going to be 0.176. Can you guys see that? Okay, so it's I'm going to n is equal to 9, x is over here at 3, and p is 0.2, and I go to where this meets,
right,
and it's
right. Yes.
0.176. Okay? So what's the probability that exactly 4 out of 9 are red?
0.066.
4 out of 9 are red. Sorry, let me write this, just so your notes are. So I go to x is equal to 4,
0.06.
and I get 0.066. And that's with p equal to 0.2. Alright, is that okay?
Yes.
Alright, so what's the probability that I get 3 or 4 red M&Ms?
We have to add them.
That.
Add, subtract, what do I do? I add them together. Why?
Because you said or.
Or.
Because they're or
It's
and they're
times,
mutually
right?
exclusive, right? If I grab a handful of 9 M&Ms, I cannot have 3 red M&Ms at the same time I have 4 red M&Ms. I'm either going to have 3, or I'm going to have 4, or I'm going to have some other number. They're mutually exclusive, so I just add them, okay? So or means you add them together, but you subtract off any overlap, but there's no overlap in getting 3 or 4 red M&Ms. So the total answer here is going to be 0.176, 0.066, 0.242. So about 24% chance that I get 3 or 4 red M&Ms. Okay. Let's try one more example here where you're going to be using the table. Okay. And again, please look over these other examples that I put up here. Okay. You know, our table doesn't have all of the n's and the p's. The n's only go up to a certain number and things like that. So don't worry. On the test, I'm only going to give you.
Which table are you gonna put on? Are we gonna have either one?
I will give you the normal table and the binomial probabilities table, okay?
So, we're gonna name it A2 and A3,
I'll give you A2 to A5, okay? 4 pages of tables. Alright? Okay, so let's try one more.
Wait,
So, yes?
So just a quick question. For the row, you decide based on X, but for the column, you decide based on P?
Yes. Well, the row is actually based on n and p. N and x. The row is based on
Oh,
n
yeah,
and x.
yeah.
Okay.
Right.
So let's say, okay, Chris Paul shoots free throws.
You said 1 minute.
With p equal to 0.9. So he's a 90% free throw shooter. Let's just say that, okay? He's a basketball player. CP3, okay? For the Clippers. And let's say he shoots, let's say 7 free throws. One night. Okay. What is the probability that he makes 6 of them. Exactly 6 of them. So not 7 out of 7, but 6 out of 7.
So n would be 7, right?
So I'll give you a minute here. NPX, and then figure out your answer. And then I'm going to put up another problem here. Wait, sorry, let me change. Okay. Did we get the first answer?
Yeah.
Okay, well, let me see. N is 7, P is what?
0.90.
0.9, X is
6.
6, and the answer is
0.372.
0.372. Okay, the probability of winning a scratcher is 5%, 0.05. A man buys 5 scratchers. What's the probability he wins at least once?
0.204.
Probability he wins at least once?
0.204.
204?
1.156.
Not quite.
Really?
So what does at least once mean?
The x is 1.
1 minus the probability of none, right? At least once means he can win 1 time, 2 times, 3 times, or 4 times. Okay? The only time he doesn't win at least once is when he wins 0 times. So probability of at least once is 1 minus the probability of winning 0 times. So in this case, your n is 5, your p is 0.05, and your x is 0, which gives you a probability of 0.774. Okay? But that's not the answer. Our answer is 1 minus 0.774. Okay? So this gives us that, but our answer is equal to 1 minus 0.774.
Why is x 0?
Yeah.
0.226. Why is x 0?
Yeah.
That's the complement
He wins at least
of
once.
winning at least once. Okay, so always think about this. What does it mean to have at least one of something? It's the opposite of having none.
So it is at least always minus by
So
1.
at least one is always going to be the complement of having none. Okay, study these examples. You're going to see something like this on the midterm. Okay? All right. Good luck as you guys study. We'll see you guys next week.